the FOIL method. And we do it the same way. I'm going to remind you, FOIL stands for first, outer, inner, last. FOIL. So we're going to do the first one. So we'll take the 4 times the 5. I'm going to write it out. Now, you may not always write it every step out like this, but I want to make sure you see it at least this first time. And then we're going to take the outer. So I'm going to take the 4 times 4 times the square root of 2. So I'm going to, those are both positive, so this is positive 4 times 4 square root of 2. Then we take the inner, and the inner are 2 square root of 2 times 5. So that ends up being, I'm going to write it as 5 times 2 square root of 2. And then finally, I take the last, which is 2 square root of 2 times 4 square root of 2. 2 square root of 2, 4 square root of 2. I'm going to put them in parentheses so that we can see them multiply together like that. Okay, well, let's simplify our terms here, or let's do our little expressions. 4 times 5 is just 20. That one's pretty easy. 4 times 4 square root of 2, well, 4 times 4 is 16, so I can do that part. And the square root of 2 kind of comes along for the ride, so I have 16 times square root of 2. And 5 times 2 square root of 2 is similar. I can just multiply the rational parts, which would be 10, and leave that square root of 2 there. And now, this one is where it gets a little interesting. Of course, I can multiply these two together. I can move things around, and the commutative property says I can take 2 times 4 and get 8. But then I have the square root of 2 times the square root of 2, or the square root of 2 squared. And remember, the square root of the square of a square root is the number. So the square of the square root of 2 is just 2. So I end up with 8 times 2. Well, let's do that again. 8 times 2. So this actually becomes 8 times 2, or 16. That's a 6. 16. So I've got 16. So now look what I can do. There are some like terms that I can combine. First off, I have 20 and 16. Well, 20 plus 16 is just 36. 20 plus 16 is 36. So I have that's these two right here. 20 plus 16 is just 36. And then I also have like radicals because they both have the square root of 2. So those I can put together as 16 plus 10 square root of 2, which is going to be 26 square root of 2. That's this one and this one. And then I have a new binomial that is the simplified version of the multiplication. So when I multiply these together, what happens is I can use what I've used before with the FOIL, along with what I've learned about combining like radicals and squaring radicals, and I can come up with a simple expression, simplified expression. This leads me to being able to do that with a special type of binomials, which are called conjugates. Conjugates are any special pair of binomials where the only difference is one is the sum of the two terms, and the other one is the difference of the same two terms. So here's an example of that for you. we have 4 minus the square root of 3 times 4 plus the square root of 3. Something special happens when you multiply conjugates. And you should kind of remember this because this is kind of the backwards when we of factoring the difference of squares. And we've done this before. So this should look a little familiar as it happens, but we're going to go ahead and use the FOIL. We're going to go ahead and use FOIL and try and simplify this problem is multiplying it together again. So I use the first, which is 4 times 4, which is 16. That's the first. The outer, which would be 4 times the square root of 3. So then that's a positive. 4 times the square root of 3 times the inner, which is the negative square root of 3 times 4, so that's going to make my number negative. So I'll have negative 4 square root of 3. That makes it the whole thing negative. Times my last. Looking for my other color. Well, let's go ahead and use blue. My last, which is the negative square root of 3 times the positive square root of 3, which means I've got negative square root of 3 squared, which we should know what happens there. Okay, so let's look at what happens here. I have the negative. These two terms right here are the opposites of each other, and anytime you add opposites, you have 0. It's just like I said, I have 4 and I subtract 4, well, that's 0. So these go away. They become 0. They cancel each other out. So I'm just left with 16 minus, and of course this is 3, or the square root of 3 squared, which means that is just 3. And that leaves me 13. I have just gone from a irrational radical expression, or the multiplication of radical binomial conjugates. And remember, radicals are almost always irrational, and come up with a rational number. This is really important because remember when we talked about simplifying radicals, is that if we got a radical in the denominator, that was not simplified. So this gives us another tool to be able, in some cases, to rationalize our denominator and come up with a simplified radical expression. So let me give you an example of that. Here I have a radical expression with a radical in the denominator, and it is a radical binomial. Now, this only works with radical binomials that are square roots, just to let you know, which for some reason are what are in the book. So we'll be good at that. Anyway, so here we are going to rationalize our denominator, because remember, when we have a simplified radical expression, we cannot have a radical in the denominator. So what we do is we multiply by the conjugate. So what is the conjugate of 3 minus the square root of 6? Well, the only difference with a conjugate is it has a plus sign, or the other sign. This one's a minus, so our conjugate has a plus. If this were a plus, our conjugate would have a minus. So I'm going to multiply by this and hopefully get a rational number. But remember, when I multiply fractions to simplify it. I cannot just multiply the denominator by it. I also have to multiply the numerator. So here we go. And remember that means, and they have to be the same, so really I'm multiplying times 1, and anything times 1 is still itself. All these wonderful properties come into play with this. So anyway, so let's look at what we got here. Let's go ahead and do the numerator. That's really not that difficult because there's not that much going on. We end up with 4x times 3. Well, 4x times 3. 4 times 3 is 12x. And 4x times the square root of 6 is just 4x times the square root of 6. So that one's pretty easy. Okay, so that's my numerator. My denominator, let's see if this works. Let's see if this actually rationalizes it. My first is 3 times 3, which is 9. My outer is 3 times the square root of 6. And my inner is going to be 3 times the negative square root of 6. So they cancel out. And then I have my last, which is the square root of 6 times the square root of 6, which is 6. So minus 6. So it ends up being 3. So I end up in the end having 12x, see if I can fit it in here, plus 4x square root of 6 all over 3. And we're done. Whoops, there goes the cap. So, that is rationalizing the denominator. So it struck me as I've done the last couple of few that at the end of my videos I just kind of like expect you to understand it, and you really haven't had any practice. So I've decided to add a few examples at the end, and I'm going to pretty much show you the examples and leave it up to you to pause the video, try the examples, and then if you continue I'll show you the solutions. So I have 3 examples here. 5 times the square root of 32x plus 4 times the square root of 98x. These are all ones that we're trying to simplify. The second one in red is 1 plus the square root of 72 times 5 plus the square root of 2. And the last one is 3 plus the square root of 2 over 3 minus the square root of 2. I'd like you to, at this point, pause the tape, look through your notes, or maybe go back in the tape and look and see if you can do it, and put the things together and try these problems. I hope you've tried the problems, and even if you haven't, here are the solutions. Once you do all the simplification on this one, you end up with 48 times the square root of 2x. Here we had another multiplying the binomial with a little bit of simplification in here. We're left at the end with 17 plus 31 square root of 2. And on the last one, we rationalized the denominator by multiplying by the conjugate. So in the end, you get 11 plus 6 times the square root of 2 all over 11. Hope you did those on your own, and I'll see you in class.